Hello everyone. Today we are going to look at the different communication modes of the PISA-M and how they work. These modes are important because they show how the PISA-M communicates its status to a connected PLC or control system. This helps users detect faults, support troubleshooting, and better understand what is happening in the application. We will also see how channels can be monitored and reset, and depending on the selected mode, even switched on and off individually. So let's get started. Before we look at the different communication modes, let's first take a brief look at the setup and what is shown on the screen. In the video, you can see the PISA-M on the right-hand side. Here, we can identify the various connected cables. At the top, we have the input terminals. At the bottom, we have the output terminals. In between, we can see the LEDs and the buttons for the individual channels. There are also two particularly important signal interfaces. First, there is the control signal inputs, connected via terminals 3.1 and 3.2. Second, there are the status signal outputs, connected via terminals 3.3 and 3.4. These two interfaces are essential for communication. The status signal outputs provide information about the current status of the device. The control signal input is used to trigger a reset. The left-hand side is a simplified visualization. It represents how a PLC or receiving device would interpret the signals from PISA-M. This setup is not available in exactly this form in the real application, but it helps us explain the communication behavior more clearly. On the screen, we can see a circuit diagram that illustrates the system behavior and indicates whether power is being supplied in the selected mode. When the switch is in the down position, power is supplied from the PISA-M to the status indicator lamp on the left-hand side, so the lamp turns on. When the switch is open, the lamp does not receive any power and remains off, which is indicated in gray. This information comes from the status signal output terminals 3.3 and 3.4 of the PISA-M. We can also see a reset button. This button controls terminals 3.1 and 3.2, which means it sends a reset signal to the device. Depending on the communication mode, this signal determines how the reset is triggered. Now that we have an overview of the setup, we can take a closer look at the different communication modes. Let's start with status communication, beginning with the tripping alarm. On the PISA-M, all LEDs are green. On the monitor, the status lamp is gray, which means it is off. In the circuit diagram, the switch is open. This indicates that the system is operating normally and that no fault is present. A reset could be sent in this state, but it would have no effect because there is nothing to reset. If a channel trips, in this example, channel 1 and channel 3, the status changes immediately. On the monitor, the status lamp turns red, indicating that one or more channels have tripped. It does not distinguish between one tripped channel and several. It simply shows that a fault is present somewhere in the system. This means that an alarm is active and that at least one channel has tripped. In the circuit diagram, the switch is closed, showing that a reset is required. Once we press the reset button for 1 second, the system returns to normal operation. In practical terms, this would simply mean briefly applying an input signal, in the form of a voltage, to the PISA-M and then removing it again. The status lamp turns gray, off again, and the LEDs on the PISA-M return to green. So the status lamp only shows the overall status of the system when a channel trips. If a channel is switched off manually, this does not trigger an alarm. In summary, this means that for the tripping alarm, if at least one channel trips, an error has occurred. Now let's look at the channel off alarm. Initially, this mode operates very much like the tripping alarm mode. If a channel trips, the status lamp on the monitor turns red. However, there is one important difference. If a channel is switched off manually, the status lamp also turns red. This indicates that the system is no longer in its normal operating state. At the same time, we can see in the circuit diagram that the switch is closed and the status indicator lamp is on. In this case, pressing the reset button on its own is not enough. The channel must be switched back on manually. If the channel remains switched off, the red status indicator will stay active even after a reset command has been sent. When the channel is switched on again, the status indicator light turns off and the system reverts to its normal state. In summary, this means that for the channel off alarm, the channel off alarm responds not only when a channel trips, but also when a channel has been switched off manually. Now let's take a look at the OK signal. Here, the logic works in the opposite way. In normal operation, the status lamp is green, as long as all channels on the PISA-M are also green. In the circuit diagram, the circuit is closed, showing that everything is working properly, and that the status information is being received via outputs 3.3 and 3.4. If a channel trips, the status lamp turns off. At the same time, the circuit opens. This means that the PISA-M is no longer providing a valid status signal. When we press reset for 1 second and the reset is successful, the circuit closes again and the status lamp turns green. One major advantage of this OK signal is that it is transmitted continuously to the receiving device. As long as everything is working correctly, the status indicator lamp stays on. If the voltage is lost, the receiving device detects this immediately and can pass on the corresponding signal without delay. In summary, this means that for the OK signal, the OK signal provides a continuous signal during normal operation, which is lost if a fault occurs or if a channel is switched off manually. To summarize, these three communication modes indicate the system status, but each one works slightly differently. The tripping alarm indicates that a fault is present. The channel off alarm also responds if a channel has been switched off manually. And the OK signal provides a continuous signal during normal operation, which is lost in the event of a fault or a channel has been switched off manually. This gives us a clear overview of how each mode behaves and how the status is communicated. Thanks for watching. For more, check out our PULS channel or our website.